Hello, my name is Markus Borg. I'm here to present this work together with Joshua Bronson, my colleague at RISE Research Institutes of Sweden. And this is work done in collaboration with two great students at Lund University, Linus Christensson and Fredrik Olsson, and also four engineers from Infotiv, Olof, Lennartsson, Elias, Sonnsjö, Hamid, Ebabi, and Martin Karsberg. And the title of this paper and talk is Exploring the Assessment List for Trustworthy AI in the Context of Advanced Driver Assistance Systems. And this is research done connected to three research projects: AIQ, Smile, and Values. Joshua, are you with me?
Thanks, Marcus. Appreciate it. Okay, really quickly, a little bit of background to understand our project. In 2018, the European Commission set up what's called the High-Level Expert Group on Artificial Intelligence. And as a part of that group, 52 people about, made up of experts from academia and government and industry, in about a year, 2019, they produced their first paper, which was called the Ethics Guidelines for Trustworthy AI. How do you develop trustworthy AI? Those guidelines pointed out that trustworthy AI should have at least three things. It should be lawful, ethical, and it should be robust. Further, building on top of that, it should have 7 key requirements. So it should have these that you can see here. Those key requirements are good. So when developing artificial intelligence, you want to make sure that it meets these, but more detail was needed. So in 2020, another paper came, which was called the Assessment List for Trustworthy Artificial Intelligence, Trustworthy AI, called ALTI for short. So that assessment list gives us more practical detail about what to do in the process of developing an AI. And this makes sense then of our research questions, which the first one is, what extent does ALTI, this assessment list, to what extent is it applicable to the development of ADAS? And ADAS is Advanced Driver Assistance Software, so a particular kind of AI. So the question is, to what extent is this list applicable to the development of this kind of AI? Second question is, according to ALTI, this assessment list, how should SMERC, the development of this particular one that we're developing, how should it go about? How do we do that to meet those criteria? Those are our two research questions, and that gives a little bit of sense of the background. But now, more detail on the technical aspects. Back over to Marcus.
Thank you, Joshua. I'm going to talk a little bit about the automotive software engineering context, and especially advanced driver assistance systems. So when it comes to automotive software engineering and safety, functional safety, it has traditionally been this ISO 26262 standard that has permeated the entire development context. That has been the backbone of how to develop safe automotive software, and it basically consists of parts related to management, parts related to supporting processes such as configuration management, and then also this core of requirements engineering, architecture, and how to break it down into detailed design, verification, validation, traceability, and very rigorous engineering practices. But things change a bit now. We used to have explicit source code instructions programmed by human developers. Now with AI and machine learning, we increasingly let go of some control and let the logic be embedded instead in parameter weights in neural networks. Actually, just saying how information is propagated from one side to the other in the neural network. This means that established engineering practices are now less effective. For example, code coverage is very central in ISO 26262, but it has less value now when the logic is embedded in the training data. And the same thing goes for code reviews. Still a good idea to do code reviews, of course, but they kind of miss the target now. You should probably review your training data. And this is the whole issue. So YOLO here, it's an example of a very popular object detection algorithm. It is trained, it is not coded, so this forces us to think in different ways. So when dealing with safety assurance, and assurance in general can also be ethics assurance, for example, it's about developing a corresponding assurance case, a structured argumentation that the system is trustworthy, safe, ethical, or what it might be, and then you support this argument with some hard evidence, for example by testing things. I'm now going to introduce the case under study, the case, the system we discuss in this paper. And the system is SMERC. It's a pedestrian emergency braking system. And it evolves as an open source project on GitHub. You can find the source code and training data here. So what we have here, we have a vehicle with a forward-facing mono camera, and we also have a radar unit, and we have this acute warning area defined in front of the vehicle, and we have a pedestrian. So if the pedestrian enters this or is expected to enter this acute warning area, then the car brakes. This is SMERC in a nutshell. From a bird's eye perspective, the system works like this. So we have forward-facing sensors, as I said, radar and camera. And the radar unit provides some object tracking with relative speeds. This is standard features for automotive radars. And this goes into some radar logic that calculates the time to collision for objects, assuming that everything keeps constant speeds and trajectories. If any object has a time to collision of less than 4 seconds, so collision is imminent, then the camera image is sent to this pedestrian detection component, and that is a trained system then, YOLO, as I mentioned before. And it checks the camera image to see if there is a pedestrian there, and if the pedestrian is indeed there, well, then the signal goes to your braking unit. So one might wonder also, what shouldn't the driver be warned if something else appears in front of the vehicle, not only pedestrians, like an elephant would also be fairly bad? The answer is that an automated vehicle has a set of those complementary ADAS systems. Large animal collision, that would be another system then. And for safety assurance purposes, it is wise to treat human beings separately. But how do we develop this system? Well, it's a bit different compared to this typical rule-based software engineering system where you write rules in explicit source code. Now we collect training data and we annotate the training data. So this is from a simulator we are working with, and it's annotated pixel by pixel, so it's segmentation of the image. And then we train the model, and we get all those parameter weights then. And then we put this in the ADAS. We have 2 research questions here in this paper. The first one is, to what extent is Altai applicable to ADAS development? And the second one is, according to Altai, how shall SMERC be designed to meet the criteria for trustworthy AI? Okay, Joshua, over to you.
Thanks, Markus. Okay, so what did we find? What are the conclusions? Well, we had basically 3 conclusions and then 3 recommendations that we thought might be useful for Altai to make it even more useful for organizations developing AI. So the first was that Altai is largely relevant. And that's a good thing. Most of the requirements, they found a place that were helpful in the development of an AI project like ours. Most of those were in areas that required a focus on robustness or safety, and that's maybe not so surprising. SMERC is in a way too limited for some of the recommendations, and this is one of the things that we found, was that some of the recommendations focused on, for example, the societal or environmental concerns or human agency, and SMERC just wasn't relevant to Smrk. It's a particular AI within a larger ecosystem that makes up the vehicle, how the vehicle functions. It's not interacting directly with people, so worries about over-attachment, for example, to an AI, or understandability of the AI for a person using it weren't directly relatable, because the ADAS doesn't relate to the person directly, relates to the car. Another aspect is that it's about braking. Smrk is about braking in a vehicle, so it's just quite limited in what it's doing. So larger societal or environmental concerns are not particularly relevant. So some of the recommendations weren't relevant and some were. What are the 3 suggestions that we had for Altai to make it even better and more useful? We thought that there should be support for organizations at different levels. So when you're developing an AI, there's a sort of conceptual level, there's the development stage, and then there's the actual operations. Sometimes those can be done by different companies. They can be done by the same company, but there are different concerns at different points. And it would be helpful to have a sense of how that can be understood from the development of an ethical or a trustworthy AI perspective. And then domain-specific would be good, adaptations. So can we develop an Altai that is relevant for the automobile industry or for the med tech industry, and so on? So is there a way to make this more specific to the kinds of AI that you see in these different areas? Because there are different types of concerns that come up. And then some reorganization of just the material itself would be helpful, and would help support sort of just the practical applicability. How can you actually use it? Some of the things were a bit redundant and in different order, and depending upon what you develop, if you're developing it in practice, actually going through the process, thinking of it from that perspective, as instead of thinking of it from the conceptual perspective of those 3 claims that should be ethical, legal, and robust, and then the 7 requirements, and then laying those out, but rather thinking of it of the workflow of developing an actual product or an actual AI. That would be helpful. Maybe that would come from domain-specific material as well. And that was our conclusion. Thank you so much for your time.
Welcome to this talk. My name is Markus Borg. I'm here with
Joshua Bronson.
We're with RISE Research Institutes of Sweden, and we are now going to present this paper called Exploring the Assessment List for Trustworthy AI in the Context of Advanced Driver Assistance Systems. The longest title today, I think. We have a bunch of co-authors as well, 2 students from Lund University, Linus and Fredrik, and 4 engineers from a company in Gothenburg, Infotiv, Olof, Elias, Hamid, and Martin. You want to go next?
Yep. Go to the next slide, maybe. Give you a little bit of context for the background of this project. So, as was briefly mentioned in the keynote, we had the high-level expert group develop something called Ethics Guidelines for Trustworthy AI, which I'm sure a lot of you are familiar with. And that was back in 2018. And as a part of that, they had 3 different sort of things that they thought that how an AI would count as being a trustworthy AI. And the first one was that it was lawful. So that means that it complies with all the applicable laws and regulations. So lawful, and then it's ethical, and lastly, it is robust. So that's like sort of the 3 principles. And then they had some other things that went along with that. They expanded that into 7 key. And the 7 key requirements are, they're pretty straightforward. You can just put them up on there. They are that there's human agency, technical robustness and safety, privacy and data governance, transparency, diversity, non-discrimination, and fairness, then societal, environmental well-being, and accountability. So those are 7 requirements that they were saying that in developing an AI, meet these requirements, then you have something that would be considered trustworthy AI. That was the idea. However, as you can see quite clearly here, those are very broad. Something like transparency or human agency and oversight. It's a broad principle, maybe a good principle, but when we looked at trying to develop an actual system, it's not necessarily so helpful at that level. So another paper came out a year later, which was the assessment list. And this one, this background helps us make sense of our research questions for this paper. So the research questions were these. The first one was, to what extent is Altai, so that's the assessment list for trustworthy AI. That was the paper that came out after the first one. To what degree is it applicable to ADAS development? And then the second one is, according to Altai, how should SMRC, so that's the particular one that we've been working on developing, how can it be designed to meet those criteria? So if you want to make a trustworthy AI, how does this look like when you're developing an ADAS? So if we go to the next one, we can see what the checklist looks like. So it's very intense. They took those 7 requirements, and each one is broken down into lots of smaller points. And so we were wondering, how does this apply? In what way? And when you're developing something, what does it look like if you're trying to apply these requirements to the development of something like ADAS? So, Markus, you can tell us a little bit more about ADAS, the technical stuff.
Thank you very much. I have the coat hanger. Okay, so some background here, some backdrop for automotive software engineering first. So when you develop automotive software, there is this safety standard ISO 26262 that kind of permeates everything you do, and it's a rigorous standard with 11 parts right now, only 10 in the picture, but there are 11 in the latest edition, basically telling you how to do management, what you need to do in terms of supporting processes such as configuration management. And then there is this core of requirements engineering, how you break your requirements down into detailed design, how you do verification validation, what is mandated there quite a bit. Traceability is a very big part of the standard and in safety engineering in general. The problem with AI and in particular machine learning is that we no longer explicitly put all source code instructions there in the code for us to see and execute. We rather rely on trained neural networks, where the parameter weights in those neural networks, they tell us how information is propagated from one side to the other, but it's, just as we heard in the keynote, it's very hard to interpret what it actually means, and those deep neural networks are huge, can contain hundreds of millions of parameter weights. And this means the conventional software engineering standards, the mandated processes there, they are less effective now. Code coverage, for example, standard approach to argue that you have tested your source code, less effective now, means less when you rely on machine learning. Source code reviews, of course, still good to do, but the magic kind of happens in the neural networks, and those networks have been trained on data. So this is really different now. We rely on annotated training data to a large extent. And the YOLO here, as you can see, this is one of the standard neural network architectures for vision, object detection and recognition. So you need to assure compliance when developing critical stuff. For example, trustworthiness compliance, and that means you need to develop a corresponding assurance case. And that is, in a nutshell, a structured argument that the system is trustworthy, or it could be secure or safe, or whatever it is you need to assure. And then you need to support that argument with the evidence somehow. It could be formal proofs, could be test results, could be inspection protocols, and many other things as well. So we have a case under study I want to present here as well. We needed to have something concrete to discuss in our little working group. So we discuss SMRC. This is a pedestrian emergency braking system, and it is machine learning based, of course. And as you see here in the figure, this is what it is supposed to do. You have this acute warning area in front of the vehicle, and if the pedestrian and the car will appear at the same place in time and space, then the system should brake before that happens. The high-level architecture of SMRC is the following. You have two sensors. You have a radar unit and a forward-facing camera. And the radar unit detects objects, and you get this radar signature, and the radar logic then calculates trajectories and estimates time to collisions if everything remains constant. And if there is a time to collision here, less than 4 seconds, then we have a look at the camera image, and we send it to a pedestrian detection box here that is machine learning based. For example, YOLO. It returns whether or not there is a person in the picture, and if it is a person, then the system shall brake. So this is the system we're discussing here, and of course it's has been trained on. We work a lot with simulators at the moment, but how to collect the data and how to make that in a unbiased and fair way is something we discussed in the paper, because this is what is used to train the neural networks. You want to continue?
Yep, sure. So we can go back again to these research questions and just look at that one more time. So if you think about the first question, which is, to what extent is Altai, that's the assessment list, for trustworthy AI, is it applicable to ADA? So developing this system that Markus just described, SMRC, how in developing it does the assessment list apply to it? And then the second one is, according to that, how should SMRC be designed to meet those criteria? So then the question is, what did we find? And that's the key bit here. Well, I think the top level take-home point is that Altai for trustworthy AI is overall relevant, it seemed to us. There were a number of points that are important for developing a system like SMRC. So overall, it seems relevant, but there's more to it. And that's a good thing that it's relevant, but we thought there was more to it. Some of the most relevant ones were the issues that talked about robustness and safety, and that makes good sense because it's talking about a braking system in a car. You want it to be robust, you want it to be safe. That's pretty clear why those would be relevant, and all of those subpoints would be relevant for developing this kind of a system. However, there was a number of points where we thought that it missed the mark, or rather it just wasn't relevant at all for something like SMRC. And part of that was because SMRC is a very specific system. It's the braking system within a vehicle, so there are a lot of the requirements that it just doesn't relate to, like larger societal or environmental concerns, because it's about the braking in a vehicle. It's not interacting with a large number of people. So some of the requirements seem to maybe be relevant for some AIs or some intelligent systems, you might say, but not specifically for an ADAS or something that is connected with a vehicle. So we thought that there was a number of ways that it could be made more relevant. So one was that it might support organizations at different stages. So this is one of the things that we recognize, that there's before you start developing the AI, then there's the process of developing it, and then there's connecting it into maybe a value chain where it's being connected with other parts of a product or something like that. There are multiple steps in this process, and at the moment, or the paper I've written, it doesn't really mention these different stages in development. So when you're actually developing, it might be good to have something that breaks it. What kinds of questions would be relevant at different points of development? And next, domain-specific adaptations of Altai. So this is about ADAS, something that's used in a vehicle. It's a specific kind of AI in the transportation sector. So Altai is very, very general, assessment list for trustworthy AI, but it's just at a very general level. So it might be nice to have something that's more specific about developing AI for vehicles per se, or developing AI for something else. So maybe there could be a way of developing this this kind of an assessment list for something in particular, so you don't have to go through and sort of figure out what's relevant for transportation and what isn't. Yes, and then there was also some reorganization of the text to support practical applicability, and this relates a little bit to the steps of development and so on. But some of this it's clear that it's developed from sort of a top level, thinking about the ideas as a whole, but not necessarily about the way in which a company or an organization might go about actually developing the software itself. Those were our main suggestions.
Yep, that's it.
Yeah.
So I will Alt Tab and return to Clouder, I guess.
Thank you so much for the great presentation, Markus and Joshua. Right on time. That leaves us with quite 5 minutes for questions. So please feel free to ask your questions now. You can type in the chat. So while we wait for the questions, I just have a quick or probably short question. At which stage, you mentioned 3 stages, conception, development, and operation. At which stage do you think organizers are most concerned with ethical aspects?
That's a good question.
That's a good question.
Yeah. You mean what stage are they most concerned with ethics at the moment?
Yeah, in a general,
where
life cycle. Yeah.
Yeah. What would you say?
Yeah, I think the keynote touched upon that also.
Yeah.
I mean, it's not only the developing an ethical system and then leave it on the market. I mean, you need to have operations and continuous monitoring of your thing you have developed. So I think the last 2 for sure. What about the conceptual phase?
Conceptual, in a way, that's part of, again, was mentioned in the keynote in terms of having ethics by design. So you think that, but I think oftentimes that's not there, but maybe should be more. Although, like you were mentioning earlier, Markus, is how much can you shove into the by design stage?
Yeah, I get a bit stressed out with all this by design thing. I mean, you need security by design and safety by design and ethics by design. It's a lot to do in the beginning. I mean, we also need to do our work.
Need to be able to get started at this place.
But I, of course, agree that it's important along the whole chain.
Yeah.
But what a boring answer. I mean, it's important everywhere, right? I mean,
Yeah.
Yeah, I mean, I was just thinking, like, wouldn't it be more expensive to correct any ethical lapses if it happened in the operation phase or even in the development phase? The more longer that you wait to identify these lapses, the more expensive or the more damage it might cause. So yeah.
I mean, it depends a little bit on how it's found and then who ends up being liable.
Yeah, and the release management process you have, I guess automotive is still not that good at patching daily, but it's over the air updates and things like that are coming also in automotive, but we're not there yet.
Yeah, it's definitely a different industry where the release cycles are much longer than software, for sure. I'm looking at the chat for questions. Please send in your questions. Yeah, we have one by Ryan. He says, but providing checklists and frameworks to engineers might also have the drawback of shifting responsibility. That is, no one can say we followed the guidelines and we were done.
That's a good point. We before Markus and I have before, and it again came up in the keynote where there's this question about a continual process of debate or dialogue when it comes to ethical issues, as opposed to being a checklist where you can, as Ryan just said, you can mark off, we looked at something like discrimination once and now we don't need to look at it again, and that is problematic. I'm not sure what a good answer is to it, right? I mean, a checklist you can see the same kind of thing when it comes to maybe sustainability checklists, where you check off that you've done a sustainability analysis or environmental impact analysis once at the beginning, and then you don't need to do it again. And that can do a similar kind of thing where you say, well, I did my duty by checking the box, and now it's not my responsibility anymore.
It might limit your thinking, of course. You use a certified guideline or checklist, and then you stop thinking for yourself. But it's pros and cons.
But this might be part of maybe connected to like safety culture. The idea is that if you want to increase a safety culture in a company where they think about safety in a way that's different than a checkbox, you might want to say a similar kind of thing where you want to encourage an ethics culture as opposed to just having checkboxes. But how exactly to do that maybe is not so clear yet.
Thank you for the answer. And if I'm not wrong, you mentioned that there is an ethics officer working in your lab. But I can probably hold on with my question. Oh, that's okay.
He's here.
I have a direct question to you, but before that, I want to give the opportunity to the audience. There's another question by Jennifer. Or maybe we need trustworthiness monitoring based on guidelines or periodic evaluations.
Yeah.
Yeah, maybe.
Maybe. Related to the previous question, yes. Yeah, I mean, it's a good point to have periodic evaluation or something like that. Trust. I find a little bit of. I'm just thinking about the word trustworthiness because I feel like trustworthiness is a little bit of an ambiguous term, although they try to disambiguate it in the EU articles there. Yes, that's maybe not a bad idea to have periodic evaluation. But I guess then the question kind of comes, well, at what point do you do that? Let's say you develop a system that you sell on to another developer that then is folded into their vehicle, perhaps, or something like that, and then they take over it, or do you continually update it? Who has responsibility for updating the
I see.
AI itself?
I mean, in safety, talk about recertification and things. We change
Yeah.
something, and then you might have to recertify it. I guess you could reassess the
trustworthiness every.
But how often do you need
years?
to do that? It depends on what changes, I guess, between those periodic evaluations.
That's a good point. I mean, if it's a system that continually updates and learns, then maybe that would be a continual process. Whereas if it's something where you send out a patch once a year to update it, then maybe you would go along those lines.
Exactly.
Yeah.
Yeah. So you should clarify that this system doesn't learn on its own all the time. This is something you train, and then you release it
into the wild and see what happens. No.
Interesting. So I would actually end by a comment, then a question, that I think the role of an ethical officer is actually a much needed role in the software development. So Joshua, you are needed. And more of you. We need more of you.
There you go.
Thank you very much for your talk.
Thank you.
Thank you very much.